Welcome to the channel where all you gotta do is get this old CNC back operational. So I had this CNC in my shop in Ventura and kind of abandoned it because I took a job in the Bay Area. And my shop back there had three-phase power, so it was all wired up with this retrofit conversion with K-flops and inductor drives and DC servo. That's the transformer, and that's the rectifier bridge, and it goes up to a bus under that hunk of plastic. Anyway, it was all working pretty good in Ventura. I never really got to make anything on it, like I said, and then I moved it down into this shop, or up into this shop, and had a little problem when it was shipping. This front cover had like a hinge, so it would open up. Anyway, that bounced around on the road, and anyway, the whole thing fell off. So I made a new thingy many years ago. Got a new screen because that was somewhere on the side of the freeway after it fell off. Don't even know where. 300 miles, somewhere between here and there. I did take the computer out and put it in my front seat because I didn't want that to be bouncing around too much, because those hard drives don't really like that. So I still have the computer, so that's all set up. But since I don't have three-phase power here, I had to rejigger a lot of stuff. And so now I got this guy here and that noisemaker on the floor, which I'm not super happy about, but I kind of hate that kind of background noise, but it is what it is. So anyway, I'm just trying to hook it back up. There's some issues with how it's wired to work with this guy, so I'm trying to science through all that, and then I'm just going to go through. I have this circuit breaker open here. It's actually fuses. That supplies power to the transformer, so there's no DC. I think it's 400 volts DC because it's got DC servo motors in here, so there's no power going to any of that. I just have that running because I'm dumb. Now, because there's three phases of power, and the stuff that runs on single phase, which is like the transformer and a little light in here, and like some solenoids and the power drawbar, those all run on 110 volts. Power drawbar up there somewhere. So I need 110 volts to do that. And then I got this computer wired up, so these two wires here go to the power on switch. And since it's sitting here, they don't reach, but that goes to this. So you don't have to like open the cover up and push the button to turn it on. And then I kind of jumpered some wires inside this computer right here. So this supplies a trigger to turn on this power supply, and this power supply is running all this junk, the K-flop and the vector drives, and these here, these are relays. I think they're only good for like 10 amps or something. 10 amps, yeah. And then anything that's high power, I go through these solid state relays. And I know it's a big giant mess, but I kind of want to make it work first, and then I'll tidy it up. Okay, so made a little bit of progress. So this thing was working when I had three-phase power. However, now that I'm running it off of this rotary phase inverter, this thing acts like its own power supply. So the neutral and the ground have to be floating, and none of this was hooked up that way. The neutral and the ground were sort of joined. So I had to go through this thing and figure out every place where the neutral and the ground were not isolated. And let me kind of explain how this works. I got single phase 240 coming into this box here. I'll pop the cover off it, but you can see the wires in here. So that's 2 hots, a neutral, and a ground. And then they come out and go into here. And these wires are the 3 phases. Now these are the real phases. These are these like are in and out, the 280 degree phased single phase power. I don't know why people call it single phase. It's really 2 phases, but whatever. They're 180 degrees out of phase. And then this is the made up phase. This is the phase that one fakes. So I can't use this one to run 110 volt stuff. In order to run 110 volt stuff, I have to use one of these phases, doesn't matter which one, and the neutral phase, which I have coming in here and then going under this terminal block here. So that's all neutral phase. So I can run 110 volt stuff. So it's running the computer, it's running this power supply, and it's running the power drawbar, which if you push this button here, goes in, push this button here, we'll put a box underneath it so when it falls out, it lands in the box. So anyway, so I have some of this stuff documented, and the way this works, and I'm just starting to remember it, so you know more about this, I'd gladly take your advice. But basically this is the K-flop, this is the GPU that does all the math to figure out where it's going to go, and then it's communicating to the computer through this USB thingy right here. And then each one of these guys is the motor controller, the servo controller. So this is the Z-axis, this is the Y-axis, this is the X-axis. Don't ask me why they're in that order. And then this is the output signal that goes to each one of the servos, this cable here. And then these are breakout boxes, so these just communicate with the K-flop, so you don't have to hook up to a ribbon cable, which apparently I did anyway over here. But so this is just so you can get to these ribbon cable information, and then that ribbon cable information comes back from the encoders and goes into here and here. Okay, so I've scienced a few things out. Still looks like a disaster in here, but I'm just trying to figure out where all the wires get hooked up. So one of the things that wasn't working was the E-stop switch doesn't function. It's normally open, and when you close it, it's normally open still. So I ordered a new one of them, and this one works now. So we're good there. I also scienced out that you have to tell it stuff or it doesn't work. So for instance, I can push this M3 button, M5 button, and I can hear it clicking. If I go over here, M3 is the spindle on, so that's this guy right here, one that says spindle, and that's doing 2 things, right? That's turning the spindle on and then deactivating the drawbar. So, and then these ones run the spindle motor, those solid state relays, and these ones have lights on them. These are Kodak ones that have lights on them. So when I go back over here, but before I do that, I'm gonna push the tool in out button. So that totally works. I can put a tool in here. Oh, I don't have compressed air hooked up, so it's not engaging. Anyway, so that's, well, it's hooked up, it's just not, the compressor's not turned on. And then if I go M3, I hear a click, and then these buttons don't work anymore. Good. And then if I come over here, this relay has a little red light on it, and all those little red lights are on. So I've succeeded at, cobbly job here. So basically how it works is you turn that computer on over there, sitting on the table, and then that brings power through this wire right here to power the relays. And then as a default, the power supply is grounded here, and that's relay number 1. That says power supply on it. So as soon as you turn that power on, oh, and the power goes through the e-stop switch. So the e-stop switch turns this power off. It also turns off the DC power, which I don't have that up yet, but so everything turns off when this power supply goes off. All this stuff is not powered. The relays aren't powered. The vector drives aren't powered. The K-flop's not powered. And then these ribbon cables here, there's like, 16 on that? 16 of those relays. So if you short these guys to ground, then it activates that relay. And then I can run power to the solid state relays or whatever. So that's how the whole system kind of works. I've also been trying to, I have a bunch of notes in here on how everything is, hooked up, and our drawbar logic and all of the axes go to, step and direction pins and encoder pins, and so this is all written down. These are the channels for the encoder. It's a quadrature encoder, and then it's got a tick every 360 degrees. There's 1,000 of these for this. Anyway, so, and I have it written down in many places, but again, there was a couple of us working on this thing, me and Rick and Alistair, and so I'm just going back through because I know this thing kind of worked. It was not done, but it kind of worked. So I have to go back through and figure out what I did 10 years ago, 12, 13 years ago, whatever it was. And there's also, the reason it wasn't working earlier is because if you go into this program here and go to digital ins and outs, spindle's 25 and the coolant 24. These weren't turned on as an output. These were just left as, default, which is, and some of these are being set. So there is a program that looks like that defines all these things. See, it says spindle 24, define coolant 25, blah, blah, blah. Cycle starts IO 19. So I have to go through and change this C program to do all the other stuff, because I need one for a light, and I need one for mist coolant, I need one for flood, spindle on and off. Yeah, these little Z, X, Y, blah, blah, blah things. And the reset button. So I gotta hook all these buttons up. A couple of them are hooked up, right? These guys work already. But these don't get controlled by the K-flop. These are just buttons for humans, because it doesn't have an automatic tool changer. So you kind of need both hands to do that. Alright, so I got a little bit of descussifying happening, but definitely more to do. So a few additions. This turns off all power, all DC power. So there's the fuses here. From 3-phase power goes there, goes to the transformer, steps it up, rectifies it, and that puts it into the DC bus, which is up there, those capacitors. So when I hit the E-stop button, which was broken, but I got a new one. So what that does is it cuts power to this. So this fuse panel, as soon as you hit that E-stop button, this fuse panel or relay panel has no power. And the reason for that is this breaker up here is the power supply, which back feeds itself into the ground over here. So as soon as I ground out number 1 wire, which is hooked up to the ground there, it closes this relay. So when power goes away from that relay unclicks, and then it turns this power supply off. And this power supply supplies all the power to the actual relays. And those control all of the solid state relays. So if this doesn't have any power, then none of the solid state relays have any power. Well, that's not 100% true. The lube pump doesn't go through that. So if you hit the E-stop, the lube pump's the only thing that stays on. But I'm going to make this relay turn that on using that power. So as soon as I hit the E-stop, it'll kill power to this, which kills power to the K-flop, all the vector drives, and all the DC power. Now it still has power going to the relays for the coolant pump, which is 3-phase, and the spindle. But they won't be activated because this won't have any power. So there'll still be power inside this cabinet, but there won't be any power coming outside of this cabinet. So that's my strategy for safety. This didn't exist before. I did go in the basement and find this guy. I have a bunch of, actually I have every piece to this control system here. This is one of them. And this is essentially the same exact thing as that, except for this runs on 24 volts DC, or sorry, 24 volts AC, which I don't have a 24 volt bus in here. I could have just went and got a transformer out of the wine cellar that came off of this thing, but then I'd have I already got 3.3 volts, 5 volts, 12 volts, 120 volts, and 400 volts DC. I think that's enough buses. And plus the excursions in the driveway. So that's like, what, 6 buses? I don't need any more. So anyway, if I hit the E-stop button, I've already done it. It shuts everything off except for the lube pump. And I told you a little earlier that the lube pump has like a controller into it. And you can see it's not spinning. And the reason it's not spinning is it has like a timer. I have a feeling there's some dip switches in here I could switch and make it stay on longer or whatever, but I think I'm just gonna get rid of this whole yeah, I don't know how to control it. It does have a pressure thing over here. I don't know. Somebody put a lot of effort into this thing. The problem is I don't know when it runs and when it doesn't run. So the other thing I could do with this thing is instead of having it just come on when the power comes on, I could turn the spindle. And then every time the spindle comes on, this will come on. And then the problem is it'll only stay on for 5 minutes or something. So if you're running a long part, the lube pump won't be on, which isn't awesome. So anyway, I could probably do that with some logic, I suppose, but anyway, it's getting, it's getting closer. I haven't done too much descussifying, but I got these little zip tie holder doodles, so I can kind of tie these wires up a little better. And this is my neutral, because I had to separate all the grounds from the neutrals. So all my grounds are there, that's earth ground, and that's neutral. That's like 110 volts. That's the neutral side of the 110 volts. So anything that runs on 110 volts, that's one of the wires. It has an earth ground for safety, and then it has a hot wire. And then the other thing that I'm not 100% sure about is these vector servo drives. I remember having to program those. It was 13 years ago, but I remember some stuff. And this is the connector that you plug into, and I found the connector. It's with an old laptop of mine that, you know, has one of these 9-pin thingies on it. And it has hyperterminal in there, which I'm pretty sure is what we use, but I couldn't find any files. So I'm not sure how long the flash memory lasts on these things, and whether I have to like figure out what was in those before. But my plan is to just turn this guy on, push the initialization program, push the home program, and cross my fingers, and if it doesn't work, I have that guy. So I'll probably pop this cover off of here so I can manually hit the switch before it gets to the end. So in case anything bad happens, I'll just smash that and it won't like run into hard stops. So, which the hard stops are usually, you know, pretty far away from the limit switches. I've actually machined some parts before that it just barely didn't have enough travel, and I just took the limit switches off and made the extra 1/4 inch. Don't try it at home, but when it's somebody else's machine, you can do it. So yeah, this is a beast. Got to get it running. I got to make some spindles for the Bronco. I got to make a lot of stuff, but that's what's holding the Bronco project up. Doesn't look like it's being held up by only that, but that's kind of a main one. So anyway, I think this will be the conclusion of this video, but if you want to see progress on this, don't forget to hit the like and subscribe button, and yeah, and if you have any insight to these guys, shoot something in the comments or email me or whatever. I definitely am out of my wheelhouse here. Not an electrical engineer, or a computer programmer, or a software engineer, or any of those things.